The first time I came across your name personally is also a long time ago to me, which was in 1999 when you first published what's now a very famous piece of work, the hockey stick graph. Everyone, I think, who's even paid a passing interest in climate science has heard of this. Could you explain that to our audience?
Sure, and it actually tied into my PhD research in that I was interested in natural oscillations in the climate system and multi-decadal sort of oscillations in climate. So interestingly, I didn't start out focused on human-caused climate change. My research really focused on natural variability of the climate. But we realized that, there is only about a century and a half of widespread thermometer measurements and meteorological observations with which we can document, what's happened to the climate. And that's a pretty short period of time. And there was always this question. Yes, it appears that the planet is warming up and the climate is changing, but how unusual is that? Maybe that happens all the time. And so we sought to extend the record back in time by turning to what are known as proxy data. Tree rings and ice cores, corals, cave deposits, calcite deposits. They're called speleothems, but we know them as stalagmites and stalactites. Each of these natural archives records, and often they're annual layers or annual rings, so you can literally go year by year and look at the isotopes, the isotopic composition, in the case of calcium carbonate, a coral skeleton, an ice core. You can look at the isotopes of oxygen in the ice layers, and these tell you about the climate. They tell you about temperature and other variables you might be interested in. And so what we sought out to do was to use the rich information that was available in a global network of these sorts of proxy data. There had been many sort of regional studies before, but nobody had really tried to take all of the data and use modern statistical methods to reconstruct from them patterns of temperature back in time, as if you had weather maps that went back in time, but they're not from human observations. They're from tree rings and corals and ice cores. And we were able to extend the temperature record first back 600 years, and that was in 1998. Published in Nature on Earth Day 1998, the original sort of shorter version of the hockey stick that went back 6 centuries. And then a year later in Geophysical Research Letters, the full 1,000-year hockey stick. And it's called a hockey stick because what we found, obviously there's the trend of the past century. There's this warming that's taken place. When we go back in time, what we found was that warming is unprecedented as far back as we could go. You don't see spikes like that in past centuries. And instead, what you see overall is a very slow, moderate decline in temperature as you go from the medieval era, which was a little warmer, into the heart of the Little Ice Age. And that, if you like, that very slow downtrend is like the handle of a hockey stick. And then the abrupt warming of the 20th century, that's the blade of the hockey stick. That's how it got its name. The name stuck, and it did become sort of this iconic symbol in the climate change debate.